This is problem number 4 from section 5.1. It says let f of x equal 1 over 3x minus 12 and g of x equal 2x over 3x minus 12. Find a formula for each of the following expressions. Find their domains. So we're going to start with part A. It says f plus g of x, we know is f of x plus g of x, which we have 1 over 3x minus 12 for f of x, plus 2x over 3x minus 12 for g of x. When we add those, they have the same denominator, which is kind of nice. We end up with 1 plus 2x on top over 3x minus 12. So this is the expression. Now the domain. How do we figure out the domain of this? Well, we look at the denominator. What can the denominator basically not equal? So we're going to say the domain is going to be 3x minus 12 not equal to 0. We add the 12 over, and we get 3x cannot equal 12. Divide by 3, and x cannot equal 4. So the domain is going to be all reals except x equal 4. Now let's do part B. We have f minus g of x. That's going to be f of x minus g of x, which is going to give you 1 over 3x minus 12 minus 2x over 3x minus 12. When I combine those, I get 1 minus 2x over 3x minus 12. Now the domain. Again, my denominator is still 3x minus 12. So my domain is going to be the exact same as the one above. So I'm just going to say domain same as above because we use the same method, right? We would go through and set the denominator equal to 0 and not equal to 0 and solve, and we end up with 4. So same as above, all reals except x equal 4. All right, let's go to part C now. Part C, we have f times g of x, which is f of x times g of x, which is 1 over 3x minus 12 times 2x over 3x minus 12. That's going to give you 2x on top over, now we need to do some multiplication here, because remember these are two binomials. So we have 3x times 3x, which is, well, you know what? Let's just leave this as 3x minus 12 squared. That's easier to use it, leave it that way. Let's leave it like that. We don't even have to multiply them. And then we're going to do the same thing that we did before. We're going to set the denominator to find the domain not equal to 0. So we're going to say domain. We're going to have 3x minus 12 squared not equal to 0. Square root each side. When we square root this side, we get 3x minus 12 not equal to, when we square root 0, we just get 0. And there's no plus and minus because 0 is just 0. So now we add the 12 and divide by 3, and we'll get x not equal to 4. So our domain is all reals except x equal 4. And now we're going to do the last part. Need a little extra room, so I'm going to kind of write this, slide this up so I can get some extra room here. So part D. Part D, we're going to take f over g of x, which we know is f of x over g of x, which is 1 over 3x minus 12 over 2x over 3x minus 12, which is going to equal, when you have two fractions, you take the denominator, you flip it, and you multiply it to the numerator, so 1 over 3x minus 12 times, we flip this, that's 3x minus 12 over 2x. This cancels with this, and we're left with 1 over 2x for our expression. So what's the domain of that? Well, the domain of this expression, now we have to kind of watch ourselves here. Because we canceled this out, this 3x minus 12, that doesn't mean that that isn't still part of the domain. So technically, although it's 1 over 2x because we cancel these out, we have to consider 3x minus 12 as part of the domain, because if we plug a 0 in, we're going to cancel, like we're going to get a 0 on the denominator there. So we need to consider 2x, right, and 3x minus 12. So we're going to say our domain is going to be 3x minus 12 times 2x cannot equal 0. We're going to use the zero product property, so 3x minus 12 cannot equal 0, or 2x cannot equal 0. And I hope you understand the reasoning for all this. The 3x minus 12, when we're doing our divisions here, right? As we went throughout and we simplified this, these 3x minus 12s, if these were 0, we couldn't do this. So that would be a huge problem. And then at the very end, we end up with 1 over 2x. So if this were 0, it'd be a problem as well. Well, what number makes this 0? Well, that's 4, and you're about to see that here. So we're going to add the 12 over. We get 3x not equal to 12. Divide by 3x cannot equal 4. Or divide by 2, x cannot equal 0. So our domain is going to be all reals except for x equal 4 and x equal 0. So all reals except x equal 4 and x equals 0. Anytime you work a problem, if at any point you get a denominator of 0, that problem's undefined. While we're working this problem, let's say we had plugged in 0 for x right away, or not 0, 4 for x right away. We would have ended up with denominators of 0 here, which would have been undefined right away. But because we didn't plug in the 4, algebraically we can cancel these out, but that doesn't mean we forget about how we got there. So algebraically we cancel these out and we get our expression of 1 over 2x, which is true. The expression is 1 over 2x. But we have to keep in mind we cannot plug in a 4 because on the way there we would have gotten denominators of 0. And then at the very end we can't plug in a 0 because of course 1 divided by 2 times 0 is going to give you 1 over 0, which would also be defined. So the only way that this function is defined is if it's all reals except for 4 and 0.